Welcome to the video on integrals. So integration is anti-differentiation of functions. So it's undoing our derivatives of the function. So it's the opposite of doing a derivative. So if f of x, for example, equals a times x to the n plus b times x to the n minus 1 plus whatever else, your integral of f of x would be the integral of that, which equals this right here. So instead of subtracting 1 from your original exponent, you're adding 1. And then instead of multiplying by the exponent, we're dividing by it. So to our b times x to the n minus 1, we've added 1 to become x to the n, and then we divide by that n. And then at the end, you're going to put plus c, which means plus some additional constant, because when we take the derivative, the constant disappears. So we need to add some constant back. So n must be an integer, but it cannot be -1. And you always need to put this plus c to show that a constant will be added on at the end. For boundary conditions, they're used to figure out the constant term. So you'll use your given boundary information to solve for c. So for example, if dy dx equals 3x squared plus 5 and y equals 12 when x equals 1, we need to find the equation of y. So first we need to take the integral of this to go from our derivative to our original function. So to take our integral, we'll add 1 to the exponent, so this will become x cubed, and then we'll take our original constant in front of it and divide that by our new exponent. So 3 divided by 3. Then we have plus, we have no x's, so we'll just have x, and then the exponent is 1, so we'll have 5 divided by 1. So then we'll need to add a constant, so it'll say plus c, and this would be your function for y, which we can simplify to y equals 3 over 3 is 1, so x cubed plus 5 over 1 is just 5x plus c. So this would be our integral if we didn't have any boundary conditions. But we know that y equals 12 when x equals 1, so we can plug those in to solve for c. So when y is 12, that'll equal 1 cubed plus 5 times 1 plus c, because we've plugged in 12 for y and 1 for x. So 12 equals 1 cubed is 1, plus 5 times 1 is 5, plus c, so 12 equals 6 plus c, and then we'll subtract 6 from both sides to get that 6 equals c. So now that we've solved for c, we can say that y equals x cubed plus 5x plus 6. So that's how you would use your boundary condition to find your constant. Next, we have definite integrals. A definite integral shows the area enclosed by y equals f of x and the x-axis, where f of x is greater than 0. So if you had some function like this, and you wanted to know the integral from here, where x equals 0, to this value, where we could say x equals 4, your integral would give you this area here. If you wanted to know the integral till 8, for example, then your integral would equal this area here minus this area here, because this area is underneath your x-axis. When you're asked to find a definite integral, you need to write the expression out before entering it into your calculator. So for example, you would write this on your page, and then you could go ahead and enter it into your calculator if the calculator is allowed on the problem. So to put it into your calculator, you'll go to math and then FNINT, which is finite integral. Then you'll enter your lower limit, upper limit, and function using x, and then you'll put dx. So here's an image of what it would look like after you go to math and finite integral. It would look like this, and then you enter your lower limit into the bottom square, upper into the top, and then your function in the parentheses, and then you put dx. Once you do that, you can hit enter. So if you were doing the integral from 1 to 5 of 3x squared plus 5 dx, then your integral would equal 144. So that would be your area under the curve from x equals 1 till x equals 5. So here we have our first IB practice question where the calculator is allowed. It says find the indefinite integral of f prime of x equals 2x minus 4 squared. So that's part A. So to take the integral here, we don't know how to do it if there's a squared on the outside, so we're going to go ahead and multiply that out. So we have f prime of x equals 2x minus 4 times 2x minus 4. So when we distribute, we'll get 4x squared minus 8x, and then minus another 8x, so minus 16x, and then negative 4 times negative 4 is plus 16. So we want to find the indefinite integral of that. So our f of x is going to be the integral of f prime of x dx. So that's the integral of 4x squared minus 16x plus 16 dx. So this equals, we'll add 1 to our exponent, so x cubed, and then we'll divide by that 3, so 4/3, minus, this is going to be an x squared, so 16 divided by 2 is 8, and then plus, this one will just be x, so we're just dividing by 1, so plus 16x, and then we can't forget our plus c. So our indefinite integral would be f of x equals this. So that's our answer to part A. Part B says, given that f of 2 equals 6, find the equation for f of x. So f of 2 equals 6. So 6 equals 4/3. We're plugging in 2 for x, because this is our input, and then this is our output, so y. So 4/3 times 2 cubed minus 8 times 2 squared plus 16 times 2 plus c. So 6 equals 4/3 times 2 cubed, which is 8, minus 8 times 2 squared, which is 4, plus 16 times 2 plus c. So 6 equals 32 over 3 minus 32 plus 32 plus c. So the minus 32 and plus 32 go to 0. So 6 equals 32 over 3 plus c. So we'll subtract 32 over 3 from both sides. So 6 minus 32 over 3 equals c. If we get a common denominator, we'll have 18 over 3 minus 32 over 3 equals c. So c equals negative 14 over 3. Which means our equation for f of x is f of x equals 4/3 x cubed minus 8x squared minus 16x minus 14 over 3. So that's your answer to part B. So now part C says, what's the integral from 0 to 6 of f of x? So for the integral from 0 to 6 of f of x, that means we're going to put our function we've found into that integral. So integral from 0 to 6 of 4/3 x cubed minus 8x squared minus 16x minus 14 over 3 dx. So you need to make sure to write this out before entering it into your calculator on the test, because that's how you'll get full marks. So then you can go ahead and enter this into your calculator and get that it equals negative 460. So your answer to part C is negative 460. Now we have our second IB practice question. It says, below is the graph of y equals negative x minus 3 squared plus 9. Part A says, for what values of x does y equal 0? So y equals 0. So 0 equals negative x minus 3 squared plus 9. We can go ahead and distribute this out. So we'll have 0 equals negative x minus 3 times x minus 3 plus 9. So 0 equals negative x times x is x squared. Then we have x times negative 3 is negative 3x. And then we have another negative 3x. So we have minus 6x. And then negative 3 times negative 3 is plus 9. And then we have plus 9. So 0 equals negative x squared plus 6x minus 9 plus 9. So the 9's go away because negative 9 plus 9 is 0. So we have 0 equals negative x squared plus 6x. So we can factor out an x. So we have 0 equals x times negative x plus 6. So our function equals 0 if x equals 0 or if negative x plus 6 equals 0. So we can solve this second part for x. So we get negative x equals negative 6. So x equals 6. So if x equals 0 or x equals 6, then y equals 0. So x equals 0 or x equals 6. Part B says, find the integral from 0 to 6 of negative x minus 3 squared plus 9 dx. So we can go ahead and just enter this into our calculator and find that it equals 36. So that's part B. Then part C says, what's the area of the shaded region B? So to find the area of your shaded region, you would take the integral from 0 to 6 of that function. So your answer to part C is going to be the same thing as part B. So the area is going to be 36 units squared because it's area. And that's it for this question. So in summary, integration is anti-differentiation of functions. If f of x is equal to this here, then your integral of that would be this, where n is an integer but not negative 1. And then you always need to remember to put plus c if you don't have your boundary conditions. Your boundary conditions are used to figure out your constant term c. A definite integral shows the area enclosed by y equals f of x and the x-axis, where f of x is greater than 0. And on the test, you always need to write your expression before entering it into your calculator and taking a finite integral. And to find your definite integral with a calculator, you'll go to Math, Finite Integral, and then enter your lower limit, upper limit, function, and dx. That's all for this video. Thank you for watching.